All right, so to find the general solution of this differential equation, we're gonna multiply both sides by y and both sides by dx. So then on the left, we'll get y dy is equal to 5x dx. So think of it just like cross multiplying. And then we can set up our integrals and integrate. So the integral of y dy will be y squared over 2, and that'll be equal to 5x squared over 2 plus a constant c1. You don't have to put a constant on both sides because having a constant on both sides just create another constant, so it's not really necessary. And maybe you'll see the answer as like everything will be times 2, y equals maybe like 5x squared plus c2. But this is good enough. This will be a fair enough answer, at least for a calculus course. All right, for 34, here we have dy dx equals x cubed over 2y squared. So we're going to multiply both sides by 2y squared. So on the left, you get 2y squared dy. And we'll multiply the right side by dx. So we'll get x cubed dx. And then we can set up our integrals and integrate. So integrating 2y squared dy, we'll get 2y cubed over 3. That'll be equal to x to the 4th over 4 plus your constant c1. And here you'll get, that'll be pretty much your answer. I mean, again, you could multiply both sides by like 3 halves or something. Maybe you'll see the answer is like y cubed is being equal to 3/8 x to the 4th. And if you multiply c1 by 3 halves, you'll get another constant. But again, that's not an issue. This is not really like something you have to worry about in the calculus course. It's just don't get thrown off if you see a solution in like a different form than what you may have it in. Sometimes they'll have it maybe just like 8y cubed equals 3x to the 4th plus like c3 or something. So no problem there. All right, let's go through 2 more basic examples. So 35, we got y prime minus 16y equals 0. So let's rewrite this as dy dx. Let's add 16xy to both sides. And then so from here, we're going to multiply both sides by dx. So multiply the right side by dx, and then we divide everything by y. So we divide everything by y, we'll have 1 over y dy on the left, and on the right, you'll have 16x dx. So now that we got all the variables separated, we can set up our integrals. And now we just integrate. The integral of 1 over y dy is just the natural log of the absolute value of y. And the integral of 16x dx will be 16x squared over 2 plus c1, and that'll just be 8. Or 8x squared plus c1. And then remember, raise this e to this whole expression. So if e to this whole thing being equal to y. So e to the 8x squared plus c1. And this is going to be the same as y being equal to e to the 8x squared times e to the c1. Just the properties of exponents. So think of e to the c1 as just like a coefficient, as like a. And so you can write your final solution as y being equal to a e to the 8x squared. All right, let's go through one more. It's 36 here. Okay, so we got y prime equals, or y prime minus e to the y times the sine of x being equal to 0. So let's rewrite this as dy dx, and let's add this whole expression to the right, so that'll be equal to e to the y times the sine of x. And let's do this one step at a time. Let's multiply the right side by dx, or both sides by dx, then that'll cancel. And then we're going to divide both sides by e to the y. So dividing this by e to the y. And then you'll get the y terms on the left. I don't need this right now. You'll get basically on the left, you'll get 1 over e to the y dy. And on the right, you'll have the sine of x dx. And the left side is the same as e to the negative y dy being equal to the sine of x dx. And then from here, you can go ahead and set up your integrals. Integrating e to the negative y is just negative e to the negative y. Integrating the sine of x will just be the negative cosine of x plus your constant c1. And then we have to solve for y. So what we can do is take the natural log of each side. So we're going to have and let's actually get rid of this negative right now, just to make it a little easier to work with. So let's divide everything by -1. Before we do that, we'll get e to the negative y being equal to positive cosine of x. And this will just be another constant. We'll just call it C2. And then take the natural log of each side. We have the natural log of e to the negative y being equal to the natural log of the cosine of x plus C2. Not get distracted by that. And then you will just use the exponent property of logarithms. So this negative y is a coefficient. So we'll get negative y times the natural log of e being equal to the natural log of the cosine of x plus c2. And then from here, you can just essentially this becomes just 1. And we just can just divide everything by -1. And we'll get y being equal to the negative natural log of the cosine of x plus c2. And it's probably going to be absolute. Let's put it absolute value signs because you can only take natural logs of positive values. All right, and there you go. There's your solutions. All right. So hope that helps. Good luck.